Okay, so you've got the answer key attached, and hopefully you've taken a quick look over the answers to see if your answers match or if they come close. Remember that I get a little more wordy than you would. I'm going to use a little more explanation than you would, at least initially. Those extra details help me understand how much you understand each question. So include as much as possible, but at the same time, like we want to make sure you understand it. So looking at number one, A, is there a clear explanatory variable and response variable in this setting? And the answer is yes. The car weight is the clear explanatory variable. And I didn't write this down, but then that would make the fuel efficiently the clear response variable. And two reasons. The car weight is explanatory because it's on the x-axis, and that just kind of makes sense that if they've provided us a graph, that the explanatory variable shows up on the x-axis. But also just logically, the car weight, as it increases, the car's fuel efficiency will decrease. Okay, so the weight clearly affects the car's fuel efficiency. Small cars, Honda Civics, Accords, Nissan Sentras, small cars, they get pretty good gas mileage if you consider something like a full-size Cadillac or a large truck. Bigger vehicles, more weight, less fuel efficiency. Okay, so number B, part B, does the scatter plot show an association? Yes, it does. And it's a negative association. And again, two reasons. First of all, just by definition, as one variable increases and the other variable decreases, that's a negative association. Okay, so the weight increases, the fuel efficiency decreases. That's a negative association. But also, just looking at the graph, the correlation line, and I didn't draw it, but the correlation line would have a negative slope, right? So there's a line that connects all those dots, and we kind of have to ignore the outlier to some extent, though it would affect the line. This is still a linear correlation, and that line would have a negative slope, which gets us to part C, the form of the relationship. The form is linear. You've got the one outlier that's really high, but except for that one point, and again, it's not about connecting the dots. It's about, can you see a vague shape behind those dots that is directing those dots? And so this has a linear shape. Okay. D, we're asked about the correlation, and they give us several R variables to choose from. We've already talked about how the correlation is negative, and so it has to be either negative 0.9 or negative 0.6, because we've already said the correlation is negative. Can't be 0, can't be positive 0.4, so it has to be one of the two negative R values. Because of the outlier, the correlation is not as strong as it could be. Okay, without that outlier sticking way up high, then that's a much stronger correlation, and then maybe it's a 0.9, a negative 0.9. But as long as that outlier is there, this is not as strong as it could be, so it's probably negative 0.6. Now, this is one of those questions where if you can strongly defend your reasoning, you're going to get at least some partial credit, but you've got to exhibit that you understand how correlation and where all of those dots are, and how those two things play together. So part E does ask us about the one, quote, unusual point on the graph, and asks us to explain what is unusual. What's unusual is that it has a very high fuel efficiency. That car, regardless of what its weight is, has a very high fuel efficiency. That's what's unusual. If you go back up here and notice all those fuel efficiencies, it's the only one that has a fuel efficiency above 30, and it's almost 50. Okay, double what most of the cars are. All right, so that's unusual. That's one of the things that makes it different, regardless of what the car weighs. And you'll notice it is one of the lighter cars, one of the 6 or 7 lighter cars, but the fuel efficiency is so high. Okay, it's probably some kind of hybrid car or electric car, but that's probably what makes it as high as it is. So F, what effect would removing the unusual point have? So we have to realize that the unusual point not being in line with the overall linear correlation means that if we remove it, then the points that remain are closer to a linear correlation, and it's a stronger correlation. So not that you have to go into this much detail, but the new correlation, if that point were to be taken away, the new correlation would be much, much closer to a -1, right? It wouldn't be a -1 because that would suggest that all of the points are exactly on a line, but it would be much, much closer to a -1, a much, much stronger correlation if the unusual point was removed. In part G, changing the units. Units have no effect on correlation. This isn't mean, median, standard deviation. Correlation has no, an effect has no units. So changing the units wouldn't change the correlation. It might change what the graph looks like to some extent, because it would change the scale, but the correlation itself would not change. It would be the same.